Hello everyone. Continuing on our discussion on the Babylonian system, I would like to show you today how to convert from the Hindu Arabic number to the Babylonian numeral. All right. So previously we discussed about the Babylonian system, numeration system, and we introduced the numerals. They support subtraction operation as well to represent their numbers, and they follow or they use a base 60 place value system. We learned about that, and then we went through an example of how to convert from the Babylonian numeral to the Hindu Arabic system. And we saw that when converting from Babylonian to Hindu Arabic, we had to multiply each digit with its positional value, and then we added them up to come up with the Hindu Arabic equivalent of the numeral. When converting from the Hindu Arabic to the Babylonian system, we will need to do the reverse in the sense that instead of multiplication, we will be using division. All right, so we will be using division to convert a decimal number, Hindu Arabic number, to its Babylonian equivalent. All right, so let's take an example here and demonstrate the process. So I'm going to use this number 12,435. All right, so the number I'm going to work on to convert is 12,435. This will need to be represented in the Babylonian form, in the Babylonian system of numeration. In order to start the process, we will have to divide 12435 by some of the place value, or rather some of the place values in the Babylonian system. So let's go over the different place values that we learned in the Babylonian system. The extreme right hand digit has a place value of 60 to the power 0, which is a 1. And then to its left, the place value has 60 to the power 1, which is a 60. And then there's 60 squared, which is 3600, and then we can keep going. On the left, it's 60 cube has a place value of 21600. All right, 21600, 3 zeros. All right, so these are the different place values in the Babylonian system. When converting to from Hindu Arabic to Babylonian, what we need to do is we will be dividing 12435 with a place value that is closest to this number without going over. All right, so it should be, the divisor should be smaller than 12435, but it should be closest to this number. So if we go through this list here of the different place values, then we see that 3600 is closest to 12435 without going over. So I'm going to divide this number that we need to convert by 3600. This is the divisor. So 3600, and we see that 3 goes into 3600. If we multiply 3600 by 3, then we get a value here. So 3 times 3600 will give us 00801. All right, so we subtract, correct, and we get 1635 for the remainder. So keep this 3. All right, 3 will be at the position of 60 squared. All right, so I'm going to write the 3 here. Let me use a different color. 3. right? We have to keep going. In the next step, you take the remainder, all right? So now we are going to take the remainder and divide it by the next lower place value, which is 60 to the power 1, all right? So in the next step, we take 1635, and divide it by the next place value, which is 60 to the power 1. So you're going to divide it by 60, all right? And then let's do the process here. So 2 times 60 is 120. Subtract, we have 43, bring down the 5, and then we 7 times 6 is 42, so 7, and then we have 420 for a remainder of 15. All right, 435 minus 420 is a 15. So look at the quotient here, 27. 27 is going to be placed in this position, the position whose value is 60 to the power 1. So 27. And then finally, we still have a remainder of 15 here. So we have to continue with the division process. 15, just a second, 15 divided by the next lower place value, which is a 1, correct? 60 to the power 0 is a 1. So the next lower place value is a 1. So we are dividing 15 by 1, and we will get 15. Let's write that down. This is easy. All right. So the place value, the quotient from here will be the numeral in the units position, in the extreme right position, right? In the position whose place value was 60 to the power 0. So now that we have all these, the numerals or the numeric values of each of these positions, we have to translate them and write in Babylonian numerals. All right. So 3 can be written with, so here are the numerals, right? The vertical line represents a 1, and this arrow, left pointing arrow, represents 10. So we are going to use those, and also perhaps the subtraction symbol. So to represent 3, we are going to write 3 vertical lines. All right. 3 vertical lines. And remember that the digits are separated by 1 space. So let's leave a space here. And now we have to represent 27. So to represent 27, the best is to use the subtraction method. So 27 is 30 minus 3. So I'm going to put 3 left pointing arrows. Each of these arrows have a value of 10. So 3 times 10, 30. And then we put the subtraction symbol. Let's use a different color for that. The subtraction symbol, this is an operator. And then 30 minus 3. So we'll put 3 vertical lines. All right. And that represents 27. And now we have to represent 15. So let's put a space because that's a separate digit. So 15 can be represented with an arrow and 5 lines, right? 5 lines. So that's how we go about converting from the Hindu-Arabic or the decimal system to the Babylonian numeral system. I'm going to work through another example, and that's a special case where we will see that there is a digit missing from one of the place values. All right. Now, before I go into that example, I just want to correct a minor error that I made in the last example, and that is the symbol for the subtraction. All right. In the symbol for the subtraction, this arrow above the subtraction symbol should actually be right pointing instead of left pointing. So I should make it in this direction. It doesn't really matter. It's not a big deal. But just because the book shows the subtraction symbol this way, I just wanted to be consistent. So let's go on to our next example, and I'm going to work with the number 3605. So I'm going to convert 3605 and express it as, or express it in Babylonian numerals. Again, the process is the same. We will be dividing the number we want to convert by a place value which is closest to 3605 without going over. So again, Babylonian system, I've written out the different place values in the Babylonian system. Starts with 6 to the power 0, which is a 1, and then 60 to the power 1, 60 squared, 3600, and so on. And we see that 3600 is the value, place value closest to 3605. So I'm going to divide it by 3600. And 1 times 3600 is the closest to 3605. So the quotient becomes a 1. And then 3600, we write it below 3605 with a remainder of 5. All right. So what we do now is this quotient, which is a 1, will be written. I'm just going to write it below the place value we divided by. So I'm going to write the 1 in the place value for 3600. We have to continue with the division process. Our remainder is a 5. So this time we are going to take the number remainder, which is a 5, and divide it. We should be dividing it by the next lower place value, which is 60. However, 60 is greater than 5, right? We cannot have the divisor greater than what we are dividing, or the dividend. So what we are going to do is we are going to move to the next lower place value, which is a 1. 1 is less than 5, so we will be dividing the 5 by the 1. However, because we did not use the place value for 60, we did not do any division by 60, we have to write a 0 below it. We have to put a 0 aligned to the place value, which was a 60. All right. So now we can go on to the next lower place value, a 1, and divide the 5 by a 1. So we have 5 for the quotient, 5 below, and we have a remainder of 0. And we write that quotient, which is a 5, in the extreme right hand place, or in the units place, so to speak. So now we have 1, 0, and 5. We are going to convert this and rewrite in Babylonian numerals. In other words, we are going to convert the numerals to Babylonian. So 1 can be represented as one vertical line. The 0 has to be, how do we represent 0? Now remember, we put a space between digits. So I'm going to put a space, but because there are not going to be any numerals for 0, we will put an extra space for that. All right, so we have an extra space to represent 0. There's no symbol in the Babylonian system to represent 0, so we put an extra space. So there are 2 spaces really between the digit on the left and the extreme rightmost digit. 5 can be expressed with 5 vertical lines. So we write that as we just show the 5 conical shaped lines, and that's how we represent the number 3605. All right, this corresponds to 3605 in the decimal system. All right.